Then welcome to the last session this evening, where I will tell a little bit about ElasticSearch and how to integrate that with OpenEdge applications. We get that request frequently, people asking how can we leverage the potential of ElasticSearch together with our OpenEdge applications. My name is Lutz Fechner, for everyone asking. Yes, I'm the little brother from Mike. I work as a project consultant at Consultingwerk now for something like 1.5 years, and I do mainly project and delivery management, but I'm a developer myself. I did like over 15 years development, mostly C# and Java-based development, so I'm an ABL newbie actually. Some other C, C++, JavaScript experience as well. So yeah, I did a lot of web applications, so there's also quite a lot of JavaScript. Can build? Can build? It's black there? 90. Oh, wait a second. It is full HD as requested, but what I don't know is what I did. Duplicate. Duplicate is good, huh? But it's changing again to extend. Is that the trouble? It says 1280 by 800, eh? But you have no picture. Excuse me? Do you want to show something very small on the page? I want to actually open a developer studio and a browser and show real things, not just screenshots like other. I can try to switch the ports. That sometimes works. I mean, we can see here on the projector, but the stream isn't showing anything. That's the main issue we have. It says Anzeigeeinstellung. Let's try this. That looks better if we get a picture here. So, okay. So enough about me. So I need to get some time back. Consultingwerk. Yeah, I guess most of the people watching us or in this room know us. We are mostly active in OpenEdge and related technologies. We are provider of the Smart Component Library, where Mike already did a presentation today, so I will just say nothing about it and go straight to ElasticSearch. So ElasticSearch, that is a term most people might have heard in the last years. It's coming up and then in the media. The last few references in the media might not have been that good because they change a little bit their license model, which doesn't actually affect end users, but hosters like Amazon or Microsoft, because they now actually are not allowed to host Elasticsearch anymore in the newer versions. The older ones or forked ones, they still are allowed to do that. So Elasticsearch is a full-text search engine. Think of it as being a database which doesn't understand SQL and doesn't understand tables and is schemaless, but very, very fast, therefore. It is based on an API called Lucene. That's an Apache open source library that you could actually use on your own without Elasticsearch. But Elasticsearch makes it very, very easy to use Lucene and provides a lot of functionality around it to make, first of all, a REST interface to integrate it into basically everything that can talk HTTP, and makes it, or it brings a lot of features for making it fast and stable. So there's inbuilt clustering in Elasticsearch that's active by default, so you need to be a little bit careful if you have two Elastic instances in the same network that they don't start auto-clustering and transferring all your data back and forth. But if you do it right, you get from Elasticsearch a very high-performing search engine. So you throw in data and you can access it very quickly back for it. As I mentioned, schema-free, so you don't define tables, you don't even define what's going to end up there. The easiest solution is just you have JSON formatted data and you post it to it. And afterwards, you can query for that. That's very, very easy to use, but can get very complex if you need to do special queries against that. The search result quality, that's one of the nice benefits of using the Lucene API under the hood. That is providing very good results in regards to how they come back in the sorting or in the ranking. There's some relevancy algorithm that makes sure what is coming back as first result also feels like that makes sense to you. Same thing like for Google. The first hit or the first 3 hits, they are the most relevant ones, and the same usually happens for things that come back from Elasticsearch. As I mentioned, one of the things that went through the media the last months is the licensing situation with Elasticsearch. For normal end users, that meaning some people that build applications and run them on their own in their own data center, there's actually no change. It's free to use for you, unless you don't need support from them, then you have to buy a license there. Elastic is widely used, that's good, because you find a lot of information and tutorials and support people that can help you. There are different hosting options. Either you install it locally somewhere in your data center, on your development machines, or somewhere. You can use Docker images that are readily available, or if you're somewhere in the cloud, you actually, every large cloud hoster also provides Elasticsearch. Elasticsearch provides cloud hosting themselves. That's actually one of the reasons why there's this discussion about licensing, because they didn't want to do Amazon and Microsoft to do hosting business without getting any money from them. So let's do some quick examples, and for that I'm opening a browser. That's the simplest thing. So I have an Elasticsearch instance running on my PC, and that has an Spots 2000 based index in it, and there are 200,000 companies in the customer table here, and they were loaded to this. So if you want to search for something as simple as baseball, you simply can query that by doing a get to the Elasticsearch instance. And as you can see, this is returning in 3 milliseconds my result for baseball, and it searched across all the fields that are in my index and returned that in the hits array here. And let's do other examples. What I wanted to show, you can specify if you want to search only in dedicated fields, so not across all. You can say field name and call on what value you want to search for. This will obviously return the same result now, but you can specify where you want to search. Field can be configured to have different analyzer configurations like that. Yeah, I said before, it's schemaless, and you don't have to predefine what data will end up there. That was actually a little bit oversimplifying real use cases. So if you have language-specific content in the Elasticsearch instance and you want things like accents or plural singulars to be treated differently, so for French customers, all the accents, you don't want to type them maybe in your search query, but still find it, because otherwise it would be character match. You can use different text analyzers that remove that special things from your content and makes it easier for people to search. Or you can actually use, I will show that later, phonetic algorithms that allow finding things that even sound similar. So it's not only a variant of how it's typed. So for Germany, you can have, yes, please? No, it's by default, it's, let's say, the tokens that are built up for searching are on space, dot, and line breaks and so on. And you have to have a full match of a token. So baseball is a token in this query, and if you remove, let's say, the double L at the end, you will find nothing actually. Unless you do a wildcard search by adding a star or a question mark, depending if you want to expand to one of the sides. So star at the end means right side expansion, or somewhere a question mark. I mean, we can try that. It's not. We can do this and still find baseball. To the browser? Yes. Yeah. So single character wildcard is a question mark, and yes, you still find baseball, and it's not even taking care of the casing of the words. By default, you could change that by telling using a different analyzer for that field or for all fields. So the syntax for all these queries that you do, for the simple queries at least, that is inspired by the Google query language. So even for Google, you can do more complex things than just entering words in the white text box in the middle. You can search for sites or dates when they were updated. There's some documentation in Google where that is. That's usually pretty hidden. But it's there, and the Lucene guys, they simply took that over, and the Elasticsearch therefore too. Boolean queries, so you can combine terms that you look for with and or not, and also brackets and so on. There is again some documentation available about how that behaves, and you can also change some default behaviors, because if you have two terms in one query, the default Boolean operation is OR, which for some users is that feels unnatural for them, because it makes your result explode the more terms you add, and they actually want to specify. I want more words being more precise and getting less result. So you can change the default behavior there, but the default is OR. So the more terms you add, the more results you get. Wildcards, we already spoke about that. Fuzzy searches, this is something that I mentioned. You can, let's say if you don't know exactly how it's typed, so let's say country name, let's look for America, and we don't know how to spell that correctly. We can say we add this tilde at the end, and that gives us a fuzzy search. So now, where is the country name? United States of America. So it found America even though we typed that completely wrong. I mean, we can remove the tilde and we will find nothing. So hits total value 0. If we go back and add the tilde, that's bringing back results. So that's using an algorithm called Levenshtein distance. That's a mathematical way to compare words, how equally they are. And there's one stupid thing about this. You have to manually activate that. So I want this to have now a similarity search, so to say. And there's a better way to achieve that. That's even better customizable, because this thing always uses this Levenshtein distance algorithm. There is phonetic searches that is more customizable and per field defined. So in my index that I have, I set the name field of the customer, search with it using an algorithm called SoundX, which is also quite well known. Many other search engines and databases do this or support this. So if I now say name and we want to look for, I don't know, let's see what happens. For Burton, no, Burton is a stupid example, so what is my good example? Let's say if we search for urban, And we don't. So we search for urban in the name field, and we find things that are urban. So it's completely different written, but it sounds the same. And therefore, we find that. And this is predefined in the index structure. So I actually told before loading data there, this field, please treat it like that. And there are a dozen of those algorithms for different languages. So there's Kölner Phonetic, that's not for the Kölner language. It's called that way because it was invented at the Cologne University. And that is a very popular one for German language. The nice thing is you don't have to type that. So I don't have to say this tilde at the end to activate the similarity search. So ranking, that's a feature coming from the underlying Lucene API there. So each result you get has a score, and that score is calculated to give a relationship between what you searched for and what you have in that document. You can modify actually the ranking by doing three things. You can say hits in one field are more important than in another field. You can say terms in my query, they are more important than others. And you can also say a row or a document in their terminology is more important than another row, like preferred items or favorites that I want always to be ranked higher in the search result than others. Yeah, they're sponsored, correct. You can do that with that. So that's called boosting. That gives extra score in the result. So aggregations, that's one of the strong features that ElasticSearch adds over the bare naked Lucene API, because that's something they really added to that API. That allows you to do actually calculations, group counts, and other things. So I have an example somewhere here that is, let's say, a question I can ask to ElasticSearch is, I want an aggregation called sales reps, and that is on the field sales rep, and that will return in the result next to the hits, which there are just collapsed. Also the values for the sales rep. So we have this sales rep is 5 times in that result, this sales rep is 2 times in this result, and so on. So you don't have to count on the data that you get back. You can actually ask the ElasticSearch instance, give me also group count things and summed up things and so on. So number of customers per sales rep and country, you can simply formulate that in one request. In addition to the normal, let's say, search request that you do to give back analyzed results. And it's also quick as well. So. And you can also do things like sum up things, or so you could say average and count. I mean, count comes by default. You don't have to do that. So going now to the OpenEdge side of things, because that was very much on the Elastic side so far. This thing is pretty quick, especially for special things like phonetic searches and also those aggregations. The ranking is excellent, and what it allows you for, let's say, a classical database application developer is offload the search stress to something else. Think of you have your ERP system somewhere and a connected shop. Shift that load back away from the ERP system. That shouldn't affect the daily business of the users, because the web can do stupid things, as we know. ElasticSearch scales horizontally. That means if it gets slow and can't be optimized anymore, you don't have to buy new hardware. Just do another one next to it. And that builds or forms a cluster that handles more load than automatically, even including the automatic data replication. So you are not posting anymore to just one instance, you are posting to a cluster, and the cluster takes care of itself to maintain an up-to-date data in all the nodes. That's very easy. That's pretty much automatic, actually. There is some danger in that automatism because that can go wild sometimes. Yeah, in theory, that helps. The aggregations that I just sketched so far, they have to reduce some logic that you might don't want to have on the application because it's too slow, because it's too far away from the data, and you have to read too much data before you could even calculate them. You can have that on the ElasticSearch. You can use an ElasticSearch in different scenarios where you might have data coming from various systems, collect them in an Elastic instance, and access them afterwards for whatever you need them. And that is even a technology bridge. So you can have a .NET application posting to Elastic, but your ABL application reading from that, or another Java thing doing the same. GeoSearch is also something nice, so searching for distances and addresses and where are they. That's built-in capability. I never tried that, so that's why it's just one bullet there in the slide, but it's there. So let's do a more complete demo than just a few queries in the browser that I showed you. For that, I will open up my developer studio and do, let's say, a 4-step demo. One is completely loading my Sports 2000 database to the Elasticsearch instance, then searching a little bit using an HTTP client. I think we had a session about HTTP client in this summit. Then at least one, yes. Then we modify some data in the database, and then we use change capture, CDC. No? CDC, change data capture, yeah, thank you. To capture the delta data and load that again to the search engine so that we don't have to do complete loads all the time. Depends if that makes sense or not. So this is just a screenshot. We can use real code. So a complete load to an Elasticsearch instance would be 2 steps. One is export your data. So I have a temp table and do a query against it. Yeah, should I wait or make it bigger? Make it bigger. What? Yeah, now I need to find the plus on a. This is better, maybe. So it's easier to read. I mean, it's just a temp table and a data set and a query against it. And at the end, I just write that to write JSON to a file. I mean, this is just the easy part because that's the ABL part. So it's very boring to watch. It takes, I don't know, maybe 15 seconds to write that file. We can actually see here if something is happening in Beartail. Oh, it's something coming out of the database. And done. So, and if we now go to this procedure, that takes the dataset file that we just wrote and will post it to my local Elasticsearch instance. We have some API here created that helps making it easier to work with predefined schema information. I'm just calling it schema, but they call it mapping, field mappings. And then you can just say load this using that configuration to that instance. Let's do that. It's actually funny to see what happens there. So let's bring it up because it will be writing also stuff to the file system to make it easier for an Elasticsearch to understand or to actually to receive. So it's creating those bulk files here and now posting it to database, because Elasticsearch has its own JSON file format that it needs for bulk imports. That's the quick way to get data into it. And once that files are gone, a few seconds later, the search is up to date. I mean, the data we didn't change it, so there's no difference. So, but it's there now. The first hit against the index took a little bit. The next one will be quick again. That's just because we changed the data so much. It needs to feed its cache. So let's go further in the demo slides. That is search against that. So that is just, if it says search demo but has a temp table. But yes, no. Oh yeah, that's because the same temp table that I used to write the data out, I just copy pasted it here to have it there. So it should be an include file, but include files are hard to show. It's the same data that we receive now from a query. So we search for city Köln, and that is talking against my local instance again. And we use one of our HTTP clients, but you could use any one. And when we have a result, we simply pull that out of the response from the Elasticsearch and read that and just fill the temp table with the data coming back. So let's see what happens. So it's 76 milliseconds did the search take, and it's just showing me some customers that we found, and they are all from Köln, so it makes sense. Köln-Rodenkirchen, Köln-Rodenkirchen again, Köln-Ehrenfeld. So we just looked for the name of the city, and we also find the subsidiaries. That's actually quite nice. So search is simple. It's pretty much the same as you could do in the browser. For the simple ones, for more complex things like the aggregations, you actually have to build a JSON object that you post to it, defining the request. So that's more programmatic than just saying and q equals whatever I search for. Let's go further here. Incremental updates. Yeah, incremental updates. In this demo, we will using change data capture, but that's obviously a feature that you need to license, and you need an enterprise version of your database. So it's not an option for. Not needed in all the cases. As you saw, how quick I dumped and loaded 200,000 records to the instance. Maybe instead of doing increments, simply dump and load everything all the time instead of doing that. But that depends on how large your data set is, and also how long it takes to query the database to get that data. So maybe then just going to the CDC data tables and knowing already what I need to query helps the actual database. For Elasticsearch, they don't care if you give it 200,000 or 1 million records, that's there in a few seconds, because they have indexing rates of five-digit numbers per second. So one option is periodic full refresh. Simply dump everything, load everything. If that gets too large, maybe you have some update dates somewhere in the tables that you can query to know which data you actually only need and pull that out of the database. If you're lucky and have changed data capture, you can use that, which is what we're going to use in this demo now. So if we go to create changes P, that is very simple. It just selects some customers and extends the name with poet at the end. So run this. That should be quick. We can check the CDC tables if there really are changes in the database. Okay, the output is a little bit stupid, but yes, there are. So the first ID, the first part here is actually the custom ID. So yes, it did update some records. So we can export that delta now, again, the same temp table. And the query just gets a little bit bigger because it's including the CDC tables in the join. If you don't like that, because that is also pretty slow, you can use the Smart Component Library to get that data a little bit quicker. Just need to find it, where we just query the CDC tables and don't join. Create some parameters for the business entity that is sitting across that, and then dump that to the file system again. Now this time the file name will be DS customer delta. I mean, name it whatever you like. So run that, and that is very quick. And now we have something which has load delta or delta load. That does exactly the same as the full load that we saw early, but now just loads this smaller file.
So ElasticSearch has a knowledge of what is the unique component?
It has its internal ID field, which is just counting up, but you can tell what, I mean, you can override that. When you send data to it, you can say value for the ID, and then it takes that. If you don't provide one, it will generate one on its own. But in my case, if you look at the API, it says key columns and add custom. So I define that for the API. And the API, when generating these bulk files, automatically includes that in the bulk file. So that's the API taking the work for you there. So going back to my index, if I now say custom equals 1 and scroll it down, now it says the poet there, which I added. And just a poet, not should be, yes. But it is 355, and I think I know the answer why that is. I mean, it finds customer number 1, customer number 3, 2, 4, and not 5. It's customer 1670 because something, I guess, in the name, the Pete is close to poet. It's just one letter switch there. But don't ask me where the 4 is. Oh, there's customer 4. Why did we skip that? Because the order wasn't in the order. No, it should be all there. So we can reset the changes. Where are they? There they are. By simply removing the poet again to nothing. Done. Export the delta to file system. Done too. And now load it to the Elastic instance. Done. And if we go to, say, custom 1 again, the poet in the name is already gone again. So this is very, very quick. There's no real wait time. You can watch it by doing the indexing. Not here, actually. There is some other endpoint, so not the search endpoint. There's a stats endpoint, and that tells you, first of all, how many documents you have in your index, so docs count, and what it is doing right now in regards to indexing. But index current is 0. It's not indexing any data anymore. Let's look at my slides, but I think that's all I wanted to show you. Any questions? You're all happy. It's a good thing if you have a load problem, actually, and especially a load problem not concerning the main business of your application. Then pull it out into something like that. Hard-hitting, long-running queries, they can end up there. That's on a different host.
have specific searches like order date?
Yes, you can do date searches, number ranges. What other specific data type searches? No, you can do pretty much anything with it. All right, then.
Thank you very much.
Thank you very much.